Hey guys, today we're going to talk about working with proportions. So before we get actually into working with proportions, let's talk about some definitions. The first of which is a proportion, and that is where two ratios are compared to one another. Okay, and we have an example. We have y over x is equal to b over a. And then another term that we need to look at is called the constant of proportionality. And that is the constant value of the ratio of two proportional quantities. Okay? And we're going to talk about and look at the constant of proportionality right now. So what was just said makes a little more sense. So when we look at the constant of proportionality, we're basically trying to look at how the numbers in that proportion, or excuse me, in that ratio are related. Okay? So we can take our basic proportion here, y over x, and we can convert that to a formula, y is equal to k times x, where k is going to be our constant of proportionality. So if we look at the example, Clint walked 8 miles in 2 hours. What is his constant of proportionality? Well, if we take that information, we put the number of miles he walked and then the time it took into our equation, we can then isolate the k to get that by itself. So we're going to divide by 2 on both sides, and then the k is 4. So he's basically walking 4 miles an hour. Okay, it kind of goes back to like a unit rate in this case. So when we start looking at proportions, we want to know if things are proportional, okay? And for things to be proportional, for two ratios to be proportional, the ratios must be equivalent. That is the big thing. So going back to what we just looked at with the constant of proportionality, each ratio must have the same constant of proportionality, okay? There's another way that we can look at that, and that is to take the cross products. Okay, so we have our two ratios and we can take the cross products. So here we have 5/8, and that's equivalent to 10/16, or we're going to see if that's equivalent. So we can take our cross products. We could take 8 times 10, 8 times 10 cross products, and that equals 80. We could take 5 times 16, or cross products, and that equals 80. So since both of the cross products equals the same thing, it is proportional. When we look at the next example there, we have 3/7, and that is set equal to 4/8. So let's see if that is proportional. We can take 7 times 4 and get 28, and then 3 times 8 and get 24. So we end up with a cross product of 28 on one side and 24 on the other. Those are not the same, they're not equivalent, so that is not those two ratios are not proportional. Sometimes we'll be looking for a missing value. You'll be given 3 parts to your ratios, and you'll need to find the missing value. Again, we're going to cross multiply. We're going to try to isolate this x, but we're going to do that and cross multiply. So with 3/5, and that is equal to 27 over some number, we're going to cross multiply. So we're going to take our 3 and our x and multiply those together. 5 and the 27, multiply those together. We will get 3x, and that is equal to 135. And then we need to get the x by itself, so we're going to divide. So divide both sides by 3, and x is equal to 45. And that one. And here we have x over 4 is set equal to 3 over 48. So again, we cross multiply. 3 times 4 is 12, x times 48 is 48x. Remember, we need to isolate the x, so we need to divide by 48 on both sides here. So that will leave us with x on the right side, and then 12 divided by 48 is equal to 0.25. And then on this example, we have 4/9, and that is equivalent to 15 over x. Again, we cross multiply 9 times 15 and 4 times x, so we get 135 and 4x. We divide both sides by 4, and we are left with x to be 33.75. So that's how we work with some of our proportions. We're going to be practicing in class, and I will see you there. Os!